Hi. So the goal for today's lesson is to help you be able to graph equations of lines when you have a table of values, and also to be able to determine whether or not an equation is linear. So I'm going to go through these notes with you. You have your packet in front of you, and I'll try to add some detail to the notes as I go through it, and then I'll have you leave some problems for you to try on your own. Okay? So the first part of this notes is all about linear equations and what makes an equation linear. So as we go through it, the first thing it asks you is, in a linear equation, it's an equation whose graph is a line. So by definition, whenever you have a linear equation, the graph is going to be a line. It contains one or two variables. Okay, so that's it. You can only have either one or two in order for an equation to be linear. And the variables only have exponents of 1. Okay, so if you have an exponent of 2 or higher, it wouldn't be a linear equation. Also, if you have negative exponents, it wouldn't be a linear equation. A linear equation can be written in standard form. So the standard form for an equation of a line is ax plus by equals c. Now, a, b, and c have to be integers. And a and b are not both 0. Okay, so one can be 0. You can have a 0 or you can have b 0, but they can't both be 0. So here's some examples of a linear equation. So you could have something like 2y equals 8, which would be the same, of course, as y equals 4. So notice here's an example of a line that only has one variable. You could have something like 3x equals 15, let's say, which of course would be the same as x equals 5. So again, here's an example of one variable in the equation. You could have something like 2x plus 3y equals 9. That would be an example of an equation that's in standard form, ax plus by equals c. Or you can have an equation, let's say you had something like y equals 4x minus 5. Okay, so this is called the slope-intercept form of an equation, which we'll learn more about later on. So these are different types of linear equations. So the key thing is that both variables have to be raised to the first power. You can either have one variable or two variables, but that's it. Okay? So now, to graph a linear equation that's solved for y, now remember when we say it's solved for y, that means y is all by itself. So the first thing you want to do is isolate y if needed. Okay? Then you're going to make a table of values. Okay, so you want to make a table of values. And you want at least 3 values for the domain. Okay? Now, what you're going to do is once you make up your table of values, you're going to plot those points. So you're going to plot the ordered pairs, and then you're going to draw a straight line. A straight line through those points. So over here, when we said an equation whose graph is a straight line, all lines are straight. So you don't really have to say straight, but it's assumed that all lines are straight. So here's an example of a graph. See how y is already isolated for you? You have y equals 2x plus 2. So what we're going to do is we're going to make up a table of values. Now remember, x is your independent variable, so you can make up any value you want for x. So I'm going to let x equal -1, 0, and how about +1? So when x is -1, so 2 times -1 would be -2. -2 plus 2 would be 0. When x is 0, 2 times 0 is 0, plus 2 is 2. When x is 1, 2 times 1 is 2, plus 2 is 4. So now I'm going to take these 3 points and I'm going to graph them on my coordinate plane. That's what we mean when we say we're going to plot those points. So -1, 0 would be right on the x-axis. 0, 2 would be on the y-axis. 1, 4. Okay, so then you're going to connect those points and you'll have a straight line. Okay? And notice it has a positive slope Your slope is 2, so your line's going to be tilted upward. Okay. So now if you look at the next side of your sheet, or the next section rather, we're talking about horizontal lines. So horizontal lines are lines that crosses the y-axis only. The slope of any horizontal line is 0. So here's an example of an equation where you only have a y in the equation. That's how you know it's going to be horizontal when there's only a y. So in this case, y is always 5. So when you make up your table of values, you can make up any value you want for x. You can let it be -2, 0, +3, but your y value is always going to be 5. So now when you go to plot the points, so you have -2, 5, you have 0, 5, and you have 3, 5. When you connect those points, notice you're going to have a horizontal line. Don't forget to put your arrows on either end to show that your line goes on forever. Okay, so here's an example of an equation. It always has a y by itself, just a y, and when you graph it, you're going to get a horizontal line. And again, notice it always crosses just the y-axis. Okay. Now the only time it would cross the x-axis, by the way, is if your equation is y equals 0. If you have y equals 0, then your line is going to be the same as the x-axis. Okay. A y-intercept is the point where the graph crosses the y-axis. So it's this point right here where the line crosses the y-axis. So the y-intercept in this graph here is the ordered pair 0, 5. So x is 0, because you're not moving left or right, you're just going up 5. So that point is your y-intercept. Now, vertical lines are lines that crosses the x-axis only. The slope is undefined. Or you could also say there's no slope. So here we have an example of a line that would be a vertical line, x equals -4. So again, when you make up your table of values, you have to keep in mind that x is always going to be -4. Y can be whatever number you want it to be. So let's say we'll choose some positive, some negative. So how about we'll do -3, 0, and +4. So again, I'm going to plot those points. So -4, -3, -4, 0, -4, +4. And then again, when I connect those points with the line, you're going to end up with a vertical line. So again, vertical lines cross the x-axis. The only time it would cross the y-axis is if the equation was x equals 0. X equals 0 is the same as the y-axis. So this x-intercept in the above graph is going to have the ordered pair -4, 0. So it crosses the x-axis when the y-coordinate is 0. Okay, so now when we write equations in standard form, so you're going to solve so that x and y are on the same side of the equation. So basically, remember, the standard form is ax plus by equals c.
Please call 352.
So here we have an equation y equals 2x plus 6, and we want to write it in standard form. So we have to get this 2x to be on the same side as the y, and preferably you want it to become before the y. Notice that x comes before y when it's in standard form. So the way I'm going to get this in standard form is I'm going to subtract 2x. Remember, whatever I subtract from one side, I have to subtract that same amount from the other side. That's the subtraction property of equality. So I end up with the equation -2x plus y equals 6. And now it's in standard form. So when it's in this form, notice the coefficient of x we call a. So in this case, a is going to be -2. That's the coefficient of x. B is the coefficient of y. Now remember, when there's no number written in, that means it's understood to be 1. And C corresponds to the constant here, which is 6. Okay, so if you're asked to identify the values for A, B, and C, in this particular equation, A is -2, B is 1, and C is 6. Okay. So now, what we're going to do is we're going to go through these examples and see if you can determine whether or not the equation is linear. And if it is, then you're going to write it in standard form. Okay? So if we look at this first equation, you have y equals 2x squared minus 3. So I would say that this is not linear. The answer is no. And the reason why is that x has an exponent of 2. Remember we said the exponents have to be 1. So x has an exponent of 2 and not 1. Okay? Now we can't write that in standard form because that's not a linear equation. We're only going to write it in standard form if it is a linear equation. So let's look at this one. So we have two variables. So remember, a linear equation either has one or two variables. Both variables are raised to the first power. So that would be a linear equation. So we're going to circle yes. Okay, and I just explained why. Now, to write this in standard form, again, I want to write ax plus by equals c. So again, I have to bring that 2y over to the same side as x. So the way I'm going to do that is I'm going to subtract 2y from both sides. So I end up with x minus 2y equals 8. So that would be this equation in standard form. Now if you look at this one, this is an example of a line that has just one variable in it. Again, when you only have a y in the equation, that means the line is going to be a horizontal line. So this is linear, so we're going to say yes, because you have one variable and it's raised to the first power. Now, in standard form, you could just keep it the way it's written, y equals -1, or if you want to show that there's no x, you could write it as 0x plus y equals -1. So technically, when there's no x written in, that means the coefficient is 0. Okay, so this is also considered to be standard form. It's just that you're not bothering to write 0x. Okay, so I'm going to leave the rest of these for you to try for homework. And we're going to go on to the next slide. So what we want to do here is a review of what we did the other day, where we have equations. We want to make sure that we solve for y. So in each of these, you can see that y is already isolated, so we don't really have to do that first step. So now what we're going to do is we're going to pick 3 values for the domain. Okay, so domain, remember, are my x values. And you can pick any values you want for x. That's your independent variable, so x can be any value you want. All right, so how about for this one? Let's try -3, 0, and 1. Now, I'm going to substitute -3 in for x. So -3 plus 4 is +1. So when x is -3, y is 1. When x is 0, 0 plus 4 is 4. So when x is 0, y is 4. And when x is 1, 1 plus 4 is 5. So these are the points. Think of these as my ordered pairs. So these are the points that I'm now going to plot or graph. So I have -3, 1, so there's -3, 1. I have 0, 4. 1, 2, 3, 4. And then I have 1, 5. So one more. And then I'm going to take a ruler. It helps if you have a ruler, but if not, just connect those points with a straight line. Do your best with that. Okay, and don't forget to put your arrows on either end. So there is the graph of that line. All right, so let's try one more together. How about we'll skip over to number 11. Now, if you notice in number 11, it's not written in slope-intercept form. If I wanted to write it in slope-intercept form, I would put that -2x first and then add 3. But these two are really the same thing. All right, so again, I'm going to make up a table of values. So how about, in this case, I'll let x equal -2, 0, and +3. So when x is -2, so -2 times -2 is +4. 4 plus 3 would be 7. if I let x equal 0. Negative 2 times 0 is 0, plus 3 is 3. If I let x equal 3, negative 2 times 3 would be negative 6, plus 3 is negative 3. Now, if you notice, when I go to plot this first point, negative 2, 7, my graph isn't big enough. So I'm going to pick another point. How about if I try negative 1? So if I substitute negative 1 in for x, negative 2 times negative 1 would be positive 2, plus 3 would be 5. So I'm going to plot the point negative 1, 5, because at least that will fit on my graph. Then I have 0, 3. Then I have 3, negative 3. Okay, so again, I'm going to connect these points with the line. Hopefully you guys can see these. Okay. So if a point doesn't fit on the graph, you can choose a different x value so that you get at least 3 points on your graph. Okay, so now we're going to switch down. I'm going to let you do these on your own, but remember, for these, you just want to rewrite them so that you isolate y. So in this case, y is going to equal 3. Over here, y is going to equal negative 5, and so on. So we've gone through examples like that before. You're going to make up your table of values and then graph those.